Alright, this is Module 3, Lesson 1. We are defining the atom. Mainly in Lesson 1, we're looking at the history of atomic theory and the different people who have worked to help us come to where we are today. And at this point in the lesson, this should just kind of be a review or a recap of things that you've already learned. You've already done some other activities with this, so none of this should really be new to you after what you've already done. So let's get back to the PowerPoint. First, looking at Democritus again, he was the first person to have the idea of the atom, and you can read what it says about his definition of the atom. His main points that were wrong is that he thought that they were indivisible and indestructible. And what we know today, of course, is that you can divide them. However, it is true that it's the smallest piece of an element that keeps its identity. If you break it up into smaller pieces, you no longer have that element. He didn't describe anything about chemical behavior, really didn't know anything beyond this idea of atoms existing. Now, then you get to Dalton, and Dalton had an atomic theory. You need to know the 4 parts of his atomic theory. You can read them on the screen. Most of his theory was correct. Most of it is still true today. The thing that he did not understand is that atoms are actually divisible. What we know today is that they can be broken up into protons, neutrons, and electrons. These are the common abbreviations for those. So be aware of P plus, N zero, and E negative, proton, neutron, electron. But the rest of it is completely true. Like, he correctly understood that if you have atoms of gold, oops, I'm at this again. I don't really know what's going on. If you have atoms of gold, my pen is not, well, obviously PowerPoint is not working. So I don't know what's going on here. So if you have atoms of gold, all of the atoms are exactly the same. So they should be identical to each other, and each element is different from each other. So if you have silver, then the atoms of silver would be different from the atoms of gold, and so on and so forth. We've already defined compounds as elements combined and mixed in set ratios, and Dalton's theory agreed with that. And then our idea of chemical reactions, too, is here that atoms can be joined, separated, or rearranged, but you can never turn an atom of gold into an atom of silver. Now, this does not stand true once we get to nuclear chemistry, so to an extent, this is completely correct. And if it'll let me change slides, here we go. Okay, 2 at once. Thomsons Model of the atom. He did the cathode ray tube experiment, where he discovered the electron. And here is a very good image of his idea of the electron, where you have a positive charge throughout and negative scattered all over the place. His model is called the plum pudding model. You do need to know what the different models were for each man. And if you've watched Tyler DeWitt's video, which you should have watched, about all of these different theories, then you would be very clear on what all of these things stand for and how they came up with these. The atom, according to Rutherford's model was that the atom was mostly empty space. All the positive charge was located in the center. The electrons were spread around outside of that. You also need to know that he did the gold foil experiment. So you need to know what each scientist said and how they came up with these ideas. Now, according to Rutherford's gold foil experiment, you should have already seen this with Tyler DeWitt. You need to understand that if the atom had been, if its mass had been spread throughout it, then you would expect that all of the alpha particles that were shot through the gold foil, if this is one atom, would have just gone straight through. But instead, what he found was that every once in a while, they would reflect back or they would bend because they had hit the nucleus that was in the center, which led him to his idea that most of it was empty space, since most of the alpha particles went straight through, but there must be something small and something dense in the center. So this is just a recap. Like I said, it was short, so if you have questions, you can ask those. Otherwise, you should be able to do your practice problems.